it gives me great pleasure to introduce our speaker, Dawson Yee. He is also the recipient of this year's College of Engineering Alumni Merit Award. Dawson received a Master's in Electrical Engineering from here, graduating in 1987.
Yep, summer.
He spent his time first at Intel, then at Microsoft. Intel, he worked on desktop mobile server systems, and at Microsoft, he worked on a whole bunch of things that I'll just mention. He was the system architect, hardware system architect for Xbox, the first and the second. Kinect. And the first one, I think, is the best-selling consumer product in its history. And he is leading Microsoft's effort in quantum computing, among other things. He's here today to talk about how you can find your dream job.
Okay, great. Thanks, Mia.
Please,
So, I guess if any of you have ever heard Elon Musk talk, you ever seen him talk? No? Okay. I thought it was very interesting. First time I heard him talk because I was at it was for an event that he had. It was for a recruiting event, and I heard the guy talk, and I was telling my friend, he's just like us. He stutters, and he's like, he's not polished like the politicians. And I go, he's an engineer, so you'll see I'm an engineer too. Just like I told my daughter, if you give a talk, it's okay to have notes because the most important thing is what are you trying to get across? It's not a marketing thing. It's about information, and what are you trying to get across to your audience? So excuse me if I got notes. I'm not going to read them, but it just helps me guide so that I don't forget the important things to tell you. So. Maybe you've seen my abstract around, and I always get asked, how do you get to work on such cool products? Because there's a lot. I've been at Microsoft for 21 years. Xbox, and whether it's IP telephony, whether it's both versions of Hololens, now quantum computing. A lot of people ask me, it's like, wow, how did you get chosen to do that? And I was like, well, I don't know. It just happens sometimes, and hopefully in this talk I'll give you some ideas of how it worked. I can't tell you exactly because it wasn't a formula that I. Some people might say, I'm going to plan in year 1, I'm going to do this year 2, year 3. It wasn't like that. I just love technology, and you'll see, and I'm always learning, and you'll see that that's a common theme. And I think what's really neat along the way, besides the products I worked on, I've actually been in 3 reviews with Bill Gates. It was fascinating to be with that guy because, firstly, I'm a hardware guy in a software company, and he knew more than the software development manager. It was amazing. He knew more than the software guy. And I've also written white papers for him. They used to have this thing called Think Week. And what happened was, with Bill Gates is you can write a white paper, what you think the company, some important issues that he should be thinking about as a company. And what happens is a committee looks through the papers, and if it's good, they'll bubble it up to Bill. And of course, there was a few that Bill read of mine, and it was, he said stuff like, the author, the people, this VP should talk to this author about, I agree with this strategy. And then there's one where he wrote, this is very educational for me, very interesting. I go, yeah, right, okay, Bill said it's very interesting. That's kind of neat. So 3 Bill G reviews, all the products I've worked on. I think it's really neat. Okay, why are we here? Number one, it's probably because there's cookies and coffee. That's probably why you're all here. And when you finish eating, you're probably going to try to find a way to sneak out the back. So that's okay. Good food always attracts people. I remember Babbitt telling me that. Other than the posters, how many of you have seen my picture before? How many of you? How many of you? 1, 2, students. Raise your hand high. Come down here. Come here. Give me a question. Come on down. Come on, it'll be worth it. Come on down. Students. Come on. It'll be worth your time. Come on. Hurry up. People are waiting for you. So where'd you see it?
I saw it in, I think, an article a while ago.
Okay, and where'd you sit?
Out there?
Yeah, okay, that's right. And yourself?
Well, I was going to say out there.
Okay, so I asked this, they had the expeditions and this and that, and some students raised their hands. Anyone else seen it before? Come on. Okay, so. I'm running out of time, so I wasn't sure. I was gonna. Okay, hold on. Hold on. Number 1. Firstly, though, I gotta do this. Okay, I give you the shirt off the back. Thank you. So, 33 years ago.
You're right, Dawson. You're right.
Oh. So I graduated 33 years ago, and at the time, Professor Terry was new professor, and Professor Winfield were here too. And it was amazing because I was like, whoa, these professor gods, and I'm sitting here, in the audience, and now it's reversal. It's kind of weird. And then I thought about it the other day. I go, 33 years, that's a third of a century. And I go, oh man, that's a long time. Oh my goodness. But it was a brand new building. This was the Cat's Meow. I remember they're still painting it and getting rooms ready. And I remember hiding here and studying and all that kind of stuff. I thought, wow, I'm in the major leagues now. This is like, being on the Yankees team, right? It's like, wow, you're major league now. University of Michigan. It was really great. But I just got to give some credit where credit's due. Prior to coming here, I had met a lady named Wendy back in 2015, and we had a long distance relationship. She was on the West Coast. I was here, studying for Michigan. We held a long distance relationship. And eventually I graduated in December of '87. We got married. She worked at Intel with me for 10.5 years, and we shared notes, complained about people and all this kind of stuff. Had 3 kids along the way. And, she helped me find a lot. A lot of the content, I really credit her for helping me find my way to be successful. Unfortunately, I lost her to stomach cancer October 23rd, 2017. So it's kind of weird being back because it's like, okay, I'm back alone again. But, we're all here. We're a Michigan family. And what was important to her was educating the students. And that's why when I came back, I wanted to give you I wanted this talk to be more about you and less about me. Because what's important is the students here, and I look at all the professors, you've dedicated your life to helping these students learn more and do good things in the world. And this is part of my talk here to make sure to give you some hints, ideas, to maybe help you be more successful as you go into a career and do good things. So it really is about, I wish somebody had told me, because when you start working, you're gonna find out, you get on this treadmill, I gotta get promoted, I gotta work on this project. And then you're going to run into, sort of like maybe 3 to 5 years out, you're going to run into like, what else is there? And so one thing Wendy helped me find out was Mark Twain, the 2 most important days of your life are the day you're born, and does anyone know the other one? Pardon? No, Bueller? No, nobody? It's the day you know why, okay? The day you know why. That is so important. If you can find out why, it gives you so much clarity. It just gives you so much clarity and purpose of what you're doing in your life. And it's not something you're going to find out yourself, because if you ask yourself, you're going to say, oh, I'm an engineer, or I'm a mathematician, I'm a physicist. It's not. How you find out is it's your family. It's going to be your mom, your siblings, your best friends. What are you doing when no one's watching? When you're bored to death on that rainy Sunday morning, you got nothing to do, what are you doing? What do you just do naturally? And for me, it's always about, learning about taking things apart. And I actually, none of you know me really well, but I'm a Mr. Fix-It guy. So if you ask me to write a speech or do taxes or making this presentation, it just takes me freaking forever to do it. I just don't do it. But if I'm in a car and I hear something squeaking, man, I'll be underneath there and looking at the bushings and get the silicone spray out. Or the other day, the door was creaking on the bathroom. So what I do, I pulled the hinges off and I planed the door down, right? There's no hesitation, right? So I'm a Mr. Fix-It guy. If I said engineering, that would be kind of deceiving, because it would be like I mapped it to my job, and that's not true. I'm a fix-it guy. I'm not an engineering guy, okay? And Mr. Fix-It just means that I like to learn how things work, and when I find out how things work, then I can apply it to engineering principles. The other way to think about this is you'll take classes about career growth, and they're going to say, oh, what's your brand? How do you market yourself? What's your superpower? The why you're born is not a branding issue. It's not a marketing. It's you fundamentally. So I'm Mr. Fix-It, and don't try to figure out yourself because you're going to map yourself, but ask your family, your friends. When no one sees you doing something, what are you doing? And maybe it's creating something, and you got to find that out. And once you find that out, it's pretty neat, because Mr. Fix-It means I'm not the innovative person. I'm not the ideas guy. I've been on many boards where they say, okay, let's innovate new ideas. I always come up blank. Right, and any ideas, I think, it's not me. But there's other people who are brilliant with ideas. and then they come to me and then I can implement it. That's how the very first play table, that was the interactive table from Microsoft, came about. I couldn't have thought of the ideas, but once they came up with the idea, I made it work, or I'd tell you by physics why it won't work. So again, right, knowing that I'm Mr. Fix-It, so that's why, I'm not an ideas person, and that's why I can figure out ideas, because I'm always learning. I'll give you another example. It's just really stupid example, but it's a good example of Mr. Fix-It. The other day, I changed the solenoid on the dishwasher, but rather than throwing solenoid, I took it apart because I want to find out how it works. Because I go, how does this solenoid hold back 60 psi of water? And I want to figure it mechanically, because that needs to be a huge spring. It wasn't a spring. It was one of those situations where the water's balanced. I think some water comes in and it pushes it backwards, but it's just enough balance so that when the solenoid pulls back, then the water flows. Another example was, you guys will get it because you're engineers. My kids, if I told them, they looked at me and go, so what? There's this night light, like a night light you might get from Dollar Tree. And I said, I wonder what's inside it. Well, 2 diodes, 2 resistors, a diode, and an electrolytic capacitor. But what fascinated me was the switch. Instead of just a normal switch where you might have a piece of metal and it pushes down on a piece of plastic, what they did was they used like a spring off of a ballpoint pen, and this was compressed. So then in one section, it's like this. And then when you flip it the other side, it's like this. And I go, why did they do that for? And it's still perplexing me, but I thought, wow, fascinating. That's how they implemented a switch, right? Because this is like under compression, and they flip it one way, and then it springs that way, and then they flip it that way, it springs that way. It's like, wow, why'd they do that? Well, maybe one day I'll implement that somewhere. I don't know what it is. But that's just an example, okay? So that's most important, why you were born. Find that out. And it's never ending. And in fact, that Wendy helped me find that out 15 years into my career. Okay, I worked at Intel for 10.5 years. I worked at Microsoft for 21. 2 companies, all the different products I worked on, from 16 megahertz processor, first ASIC, perfect out of the chute. Worked on the very first VHDL for USB, both the host side and the controller side. Xeon processor, they were going to kill the program. I worked on that, made it happen. The play table I talked about, IP telephony, Xbox Kinect, Hololens, and now I'm Quantum. I've managed a team of over 100 people when I was working on the IP telephony, where we did everything from, I had the mechanical, optical teams, industrial design, interaction model, when you touch on the phone, how to the menus. Manufacturing, I went and negotiated supplier contracts. I was able to do that because always learning. We're on a factory build, we're visiting the factory, and the MEs are looking at their molding machines. I'd tag along and go, oh, how does that work? Oh, why are you doing desiccant on your plastics? Because you can't have moisture in the injection molding machine and it gets bad yield. Go back and look at the tooling shop. So I'm always curious. You never know. It's because I'm a Mr. Fix-It guy. I want to know how things are made, so then I can apply it to fixing things. So anyways, managed over 100 people, successful career, but in that first 15 years, I was wandering around. Basically, I was telling some students earlier today, your first job, great, you just love it, you're learning so much. Then after a while, you go, how do I get promoted? How do I get promoted? How do I get promoted? And you keep looking for that promotion. What do? You look for a job that has a higher job grade. But it didn't seem right. Something was wrong, because I'm always wanting to do something innovative, and it was fighting me, because I thought what I was supposed to do is just move up in the career path, because that's what you're supposed to do. And that wandering 15 years, it was a successful career, because I got promoted along all the way, did more and more projects, got more and more responsibilities, but it didn't feel right. And I remember even the engineers, at Intel, he was saying, it doesn't get much better than this, this is the way things are. And I was like, it just didn't seem right until I found out the day why I was born, the Mr. Fix-It. And after that happened, it's like, oh, okay, this whole managing stuff, I don't need to do managing. When I managed 100 people, they loved me. I saw people today say, oh, it's too bad you don't manage them. I'd join your group at any time. And I was like, that was because I could manage and I cared about the people, but that was conflicting with my technical interests, because I liked technical things, right? So I could manage, but I love the technology. So knowing why I was born, Mr. Fix-It tells me that I'm a technical person. So could I manage? Absolutely. I'll be an excellent manager, but this is what gets me the passion, and this is my, from the company's point of view, this is higher output from me working on these problems, because I'll get down to physics. Okay. So, why you're born, right? Originally, I didn't know anybody in engineering, right? I knew I wanted to invent circuits and invent things. I didn't know what an engineer was. To me, an engineer was the guy who drove the train. But I knew I wanted to invent and design new circuits. sad face there is because one of my first technical interviews, I had an interview at the end of the day. The guy goes, "What do you want to do?" And I said, "Oh, I want to invent new circuits and invent new things." And he goes, "Hate to tell you this, but sorry, that's not how the world works. Usually you use a cookbook and you copy designs over and you just implement things and you just pull it over." And I was like, oh, it was really sad. And I was like, wow, okay, that's how it really is. And I was like, oh, okay. And so I took that and then, took the job at Intel and then came to Michigan. And I was like, wow, smart people doing research stuff. And I thought, okay, now I have to do research. At Intel, remember I was telling you for 15 years I was searching? I thought, I'm going to be a patent attorney because I was talking, you heard that I have a bunch of patents and stuff like that. I wrote a bunch of patents and I was talking to patent attorney. He goes, oh, it's awesome because you're dealing with lots of technology, always new stuff and all this great stuff. And I go, whoa, that's me. I like technology. But what I didn't understand was the reason I didn't go with the patent attorney is because you're looking at other people's technology. So yes, it's new technology, but it's theirs. Right, and what I found out is I like to create new things, not look at other people's stuff and say, that's bogus, right? So good thing I didn't become the patent attorney because that would have been a mistake, right? Even though it looked on the surface the right thing to do, that was not why I was born, right? Why I was born was to Mr. Fix It, and that's all learning about technology. So, and a lot of times I walk around and go, why me? Why am I here? 33 years later, why am I here? Why are all you here listening to me, right? Hopefully it was besides the cookies and coffee, but there's, why are we all here? There's 7 billion people in the world. I don't understand, what's the chance of all of us being here other than some quantum explanation of randomness of why we're all here, but it's unique. So I always remember, I applied to Michigan, but most importantly, Michigan chose me. They had a choice. They could have said, we don't want this guy for whatever reason, but I applied and they chose me and I came here. I got the education and I will always remember that, okay? Because I have a choice, but Michigan had a choice and they chose me. And I'm glad to be back here also to share some of my things I learned along the way with all of you. And I hope you remember that. There's 7 billion people in the world. Why me, why you, why us here? Sometimes it's opportunity, hard work, lots of luck all the time. It just timing happens to be right. I find when I worked on all these products, it was for different managers along the way. There was never one manager, no one told me, go work on this track. What happened was it seems like every time I work on one product, when I hit version 2, then I move on, or like 5 to 7 years or something like that. That's what seems to happen because then some new opportunity comes by. And then after a while, you get a reputation. People know that, like I was explaining to students earlier today, the Kinect. When the Kinect came along, they knew there was going to be an edge-emitting laser diode in there. And everyone freaked out. Oh, we're not going to put a laser in the living room. There's no way. The thing's going to fail. It's going to hurt people, so on, so on, so on. And then they're talking in the meeting. Go, oh, is that a 3.5 semiconductor laser? Okay. Is that 1.5 or is it 1.3? I go, oh, this guy knows something. I go, yeah, I had a master's degree in solid-state optics, and I still remember those things. And so that opportunity of remembering what I worked on got me along the way. And of course, for the laser diode, we had to maintain temperature because that the Fabry-Perot cavity varies with temperature, and that changes the wavelength. And the wavelength goes to a diffractive optic, and that diffractive optics creates a constellation that moves with wavelength. So we had to control that to a fraction of a degree to maintain wavelength stability. We had that control loop. There's all sorts of safety circuits I put in there because I said, even when this thing breaks, it's got to be safe. Nobody's going to get hurt on the design I work on. I made that clear. And so that level of, it's like, whoa, okay, this guy's serious about stuff. And, work by design from Intel. We had to make things work, they had to work on paper before you commit it to. All these things build up, and that's probably why Hololens worked for me. Kinect worked for me, and then on Hololens, that was kind of natural because they said, well, this guy's not really an optical guy, but he understands, lasers, he understands waveguides, and he understands interference patterns and all that kind of stuff. And then the quantum stuff came about because the quantum was research, and they moved it into a product group. And I've worked with some of the people before, and they go, okay, this Dawson guy, he thinks creatively. He gets down to the atomic level if you need to. But if you don't need to, he's practical about it and makes products that are sustainable and work. So luck, always learning, contributing, and there'll be times where you're going to feel down, but just keep going because if you have the fundamental knowledge, it'll carry you through so much because it's just the basics that will carry you through every time. You go back to physics and think about what's the electron doing. I like to tell people that, the electrons and photons are deterministic, or at least probabilistic deterministic, unlike the humans, which are, random. Okay, scientists, engineers. This is something took me a long time to figure out. Scientists are famous people. Engineers, you don't know who they are, right? They do great stuff, but everyone knows who this guy is, right? But who's the engineer who worked on this? I don't know. Okay, and at the end of the talk, you're going to go, oh, some Kinect guy came and talked. It's okay. Okay. Scientists discover things. Engineers apply the science. So if you think of engineering, it's applied science. You're applying the science, right? And what I found in this quantum work is that, I interface with a lot of people at the national labs about technologies, and they're great at showing something work once, except to make it manufacturable, that's where they don't care. I'll give you an example. Talking to a guy at national labs, he's got a resonance structure for an optical component, and I said, what are you going to do with temperature variation? Because again, that cavity is going to change and the wavelength's going to change. He goes, I just use external tunable laser. And I go, that's a $3,000 laser. I need to do it with a $2 laser. But that's not his issue, right? His issue is to show that it can work. Right? My job is to make it manufacturable and predictable over time and make it reliable and make it manufacturable. Another thing is like grading. They said, oh, we're going to use a laser, we're going to use a grading to create multiple wavelengths from a source. And I go, okay, I need absolute wavelength. So what'll happen is, yes, you can create one grading, but when I manufacture the gradings, it's going to be injection molded. And that's basically, you squirt the plastic into a mold and it comes out. Well, over time, that mold actually wears out a little bit and the gradings will change. And also depends on the shrinkage of the plastic. That will change, so the precise geometry that he may have obtained by laser diamond turning, it's not going to happen in manufacturing, it's going to vary, okay? And so that's the difference too, is that he was using a grading for both transmit and receive, and I go, that'll work on one sample, but when we manufacture, that plastic's going to vary, even with temperature, and forget about manufacturing tolerances. Okay. Oh, the thing about the earlier slide is that you can will yourself to a lot of things, right? But again, you can will yourself. I willed myself for about 15 years. But again, when you find out why you're born, things come out so clear and clean, okay? And again, in my 30-year experience, I've been fortunate. Some things I've been deliberate, and there's choices along the way, right? You can choose to do this, you can choose that. Always remember you have choices. The modern day wizard. I was thinking about this and I was like, well, engineers, if you went back 120 years ago, we'd all be like friggin' wizards. Be like, what's going on? If I brought a flashlight out and someone says, whoa, this is sunlight coming out of this thing, right? I was like, wow, how do you even describe that, right? It's people like, wow, that's amazing. But the difference is you know what's going on, right? You understand things, you understand the physics, right? But if you didn't, you would just say, oh, sunlight comes out of this thing that this guy's holding in his, or this lady holding in their hand. That's amazing. How does that work? It's black magic. No, it's physics, right? Same thing. I run into this when I was working at Intel, EMC and RF stuff. I was explaining to some students earlier today. Anything you build has to pass what they call FCC compliance. You've got chips inside that are sending a signal down the line, right? That's some current and voltage, right? And we all know Ampere's law. N, I, A, mu. Creates a magnetic field if it's a loop. Well, that creates a magnetic field, and if that magnetic field is high enough, it's going to interfere with wireless devices, police radio, aircraft, and so on. So what happens is the FCC, Federal Communication Commission, makes you test every component, FCC-B, that's what you'll see at Part 15, below a certain level so that it does not interfere. And the idea is that anything Class B, you put it together, it does not get worse and worse and worse along the way. So at Intel, we're testing these things. And everyone says, oh, it's black magic. No one understands this EMC stuff. It's black magic, and no one understands Faraday cages and all this. And I go, actually it does. It's divergence of D equals 0. And they go, oh. And I go, yeah, that's why the Faraday cage works. Divergence D equals 0, right? The field does not go through the metal. And they go, oh, okay. But again, if you say it's black magic, it's dangerous because it means it's not repeatable. You have to be able to describe things, and eventually it has to work by physics, because then when you make products, it's consistent, right? If it's just random that something worked, you sit in a simulator and I make this pen do this, that's not a product, right? Even though you made it do it once. Okay, that's not manufacturable. This is manufacturable. That's why, this is flat on the end, because someone said it's got to stand up. Okay, so again, it comes down to physics. It's not black magic. So remember that when people tell you that. Okay. It's funny, this quote, engineering having enough time. This was Professor Zissis was here, and I remember we were writing the test, and he goes, we were like, we need more time, we need more time. He goes, the engineer, it never has enough time. That was his comment, because we said, we need more time to finish it. And I always remember that, because he's right. Once at Microsoft, we had this consultant come in, he goes, if you really want good projects, schedule your engineers for 70% workload, because then they have time to rest and do this. And then I said, excuse me, an engineer by definition is always 100% busy, because even if you schedule me 70%, I'll spend that 30% learning and optimizing and doing other things. And he goes, oh, okay, you're right. Because that's true, you will look, right? When you start working, you'll find out that you never have downtime because you're fascinated around you. There's someone's working on something different over here, someone's working different over there. Is your design right? You know, how does it really work? Okay. Some tips for me to you. Everything is important, but if you have to do something, do what's urgent and important. Those two. Always do what's urgent and important, because everything's important, right? Maybe it's a paper you have to do or something. So do urgent, important. The other thing is, when I mentor people, I say, do the things only you can do, because in a project, even as a parent, there's certain things you can do, like everyone can take out the garbage, right? But you're the only person who can pay the bills or something like that, right? So when I at work, you know, I was soldering since I was 6 years old. I used to put solder in my mouth, and you know, the lead solder, and solder with it. Yeah. It was homeopathic, I think. So I could solder better than most people at Intel, but I'm the only one who knew what the circuit did. So as much as I wanted to solder, I couldn't. I had to let it go because I knew what the circuit was supposed to do, right? So only I could do that job, right? So remember that. If you can delegate, you delegate the stuff that other people can do. Even if you have to check their work, there's only certain things only you can do, and remember, do those first, okay? I remember kind of school, I remember that talk. I know that I know nothing, okay? You'll come out with a toolbox of knowledge from Michigan, and it'll be great stuff, but you'll find out really quickly that you should know that you know nothing. Give you an example. Say I asked you to graph something, you do the two graphs, and you graphed it like this, and this actually happened lately, and you go, oh, okay, it looks like this. Well, and actually I went back to the research papers, and I found out that actually there's a point there, and it actually looked like that. And someone published this paper that, you know, internally did this, and I go, if you really look at literature, it actually does that. And again, the person was knowledgeable, they published a report like it's the greatest thing, and they found this is how it performs, but you know, always assume that you know nothing, and do your research and follow it through. Okay. This is something that burnt us. We were at Intel. If you're designing a circuit, you either copy it exactly, or you go deep into it and understand what's going on. The example was a crystal oscillator circuit. So this was back in the PC days. We designed a 60 megahertz PC, and there was a clock circuit in there with the crystal. And a friend I was working on was supposed to take one design one minute. I took the other design. He took that circuit and he goes, hey, there's a cheaper crystal here, same frequency, and he put it in the circuit. I left it as is, and I copied it exactly. And what happened was that PC, the customer was using it for payroll. This is before they had network time. And so his clock was running either faster or slower because the circuit was designed for a parallel resonant crystal. And he stuck a series resonant crystal in there. And you'll find out that the crystal, and this, I haven't looked at this for over 20-something years, you'll look at a crystal and it'll have two resonant modes. One of them is series and the other is parallel. And he chose the cheaper one, and of course the time was off, and they were complaining that payroll people were off on their time and this and that. I copied exactly because I didn't know I didn't have time to understand it. And so that's, again, copy exactly or dive deep if you're going to improve and do something different, okay? Yeah, you have a deep responsibility. Again, whether this is crystal circuit, if something doesn't seem right, because there'll be times you're under the gun, you're designing something, you have to release something, it just doesn't feel right. It'll come back to bite you 100 times because it's just not right. Spend that extra time, okay? And you know, everyone, you know, you don't know what you don't know. So things happen, but don't ever repeat the same mistake. Don't ever oversight, I forgot to do this, or I forgot, right? Don't do that. And don't give up. And remember, things obey physics, right? They have to be, it can't be just random when this one or twice it happens. There's another time where I was working at Intel on there was a device that had this cache chip, and you read 8, 16, 32, but the sequence was off once in a while, and it took us like a week to debug because we were capturing traces. And eventually we saw it, but don't give up. Things again in the electrical world are deterministic or repeatable or probabilistic deterministic. And once you understand it, it'll be clear. And I'll give you an example of this, right? We all see the, okay, we'll go back to the examples. No, it's not. Well, we all know what that is, Tacoma Bridge, right? And the younger people know what this is? Yeah, O-rings, right? And we all know SpaceX, right? Can you imagine how many people said that could never be done? It's impossible. There's no way. Control system, right? So this is like, don't give up. And once you understand how it works, it's repeatable, right? Otherwise, it's random. But because I know guys at SpaceX, and they say, yeah, we helped them review the code that went through this, right? Once you understand the physics, it's repeatable. It's not black magic, right? And I think most importantly, things don't happen randomly. Pass the knowledge forward, right? Your engineers, if you really think about it, the stuff here, the things your professors taught you, that's, we're all passing the knowledge forward, right? So physics still hold. So through HoloLens, people talk about E equals h mu. It's like, oh, you remember that? Sure. Just like I remember 6.02 times 10 to the 23rd, right? That one, I don't know why I remember that. I'm talking about, some in the quantum computing, right? We're talking about lasers and stuff like that, and we're going to use optical interconnect. And I go, yeah, so okay, you get electron that's going to create a photon, but goes up and then that transition back down. Sometimes you don't get 100% efficiency. If you transmit across a wire, you're going to get 100% efficiency minus resistance, but not all electrons are going to turn on the photons. Some of them are going to turn the phonons. So maybe that's not going to work because that phonon is in the quantum world. I explained to some people earlier today. Quantum computing, the qubits operate at millikelvin, right? I'm at 4 Kelvin and 77 Kelvin. Every watt of heat at 4 Kelvin, we have to refrigerate. It costs us 200 watts of refrigerator power. So that's why I can't use I can't put an edge emitter down in the tank at 4K because it's just going to generate too much heat, okay? Always need a KT somewhere, right? Any equation always shows up. It's amazing, And I still remember this stuff: 131.155, 850. And then it was funny. The last couple of weeks, I was in a discussion with some other university, and he mentioned solitons, and I go, "Whoa! I haven't heard that for like 30 years or 35 years." Right? I remember taking the class here with I forgot which professor it was, but they mentioned solitons, and I was like, "Okay." And then it showed up again. And I still remembered. I knew what it was. And of course, quantum wells have always been there forever. And I mentioned about, divergence of E equals 0, right? And I still remember E cross H is the Poynting vector, right? Not that I can do anything with it, but I just remember that. Okay. Come on, next slide. Okay. This is funny. I've probably interviewed thousands of people. Because I'm an as-appropriate interviewer at Microsoft. What that is when you go through Microsoft interviews, you go through the technical interviews, and then at the end there's one person. If you pass all those technical, there's one person you'll talk to at the end. That's the as-appropriate. What that person's job is to make sure you're a fit for the company, and long-term wise, you're going to succeed at the company. Okay, everyone else is doing your technical stuff. If you pass technically, the as-appropriate. So there's many times where everyone given all hires, and I might say, this person's not the right fit for Microsoft, and they won't make them the hire. Similar, if they say no hire, I can look at it and say, you know what, you should hire this person. So that's why I'm going to tell you what's going on here with, I'm just giving the background. Okay, why I've interviewed thousands, because it's only like, I don't know, 5% or 10% of the people Microsoft interviewers are as appropriate, and I'm one of them. Okay. Your first job, or if you're unemployed, yeah, you'll say I can do anything, I can learn anything. I've done anything before, and I'll because you want an offer, right? You just want it, and I don't blame you for that, and that's fine. But once you have experience, 5-10 years out, and maybe you're working somewhere, and what'll happen 5 years out is, remember, it doesn't get much better than this, and you're going to go, there's got to be something better. I'm not sure. Grass is greener. All that good stuff. Watch out when you interview, because what I don't want you to do, and say you're interviewing for Microsoft and you said, oh, I'll do anything, I want to be here. And if you're working, the last thing I want you to do is up your house, relocate to Seattle, and then find out later on that it wasn't greener, or this job was crappy, or it's like, oh, this team, what a bunch of idiots. I made a big mistake because I gave up an opportunity or my tenure at this other company. Because in 6 hours, you're interviewing us, we're interviewing you. We're trying to guess you, and you're trying to guess us, or you're trying to fool us in the interview, right? Because you're just trying to say, just give me the offer, just give me the offer. But in that 6 hours, if you have a job, you better find out what that company's like, because the last thing you want to do is up and move, and then you're a prison term for 1 year because you have to pay back the relocation expense, right? Within the year, and some companies it's longer. So you better make sure that if you come and accept that offer, that you're going to be successful there. And how do you can't, because you don't know the company. But me, as appropriate, I'll sit down with you and I'll say, what don't you like to do? What do you like to do? What are you good at? Oh, sorry, I shouldn't be telling you my interview things, but if you ask me what am I bad at, you know what I'm going to say? Don't ask me to write software. Because there's better people writing software. But if you want someone who can dive down to the engineering to physics, that's me. But if you want someone to write code, I'm the wrong guy, because at my grade level, I'm going to be way behind even a junior software engineer, right? So I'm going to tell you what I'm not good at. And I'm also going to tell you that if you guys like to do PowerPoint presentations and so on, sorry, that's not me, right? I'll sit down and I'll work through physics and all this kind of stuff with you and talk on the whiteboard and all that good stuff. I love that. If that's what you guys are looking for, I'm the guy. But if not, so be honest with yourself. When you're at that, when you're at that, looking for that job, when you're thinking for something better, because it can be a mistake. Because I've seen that many times where people come in and then after a year they're gone. And the reason why they stick around for a year is because then after a year they don't have to pay back the relocation expense. But it's bad for us, it's bad for them, right? Because we were hoping you were good, but we couldn't read your mind, and it's just not good, right? Right, you're just doing the prison term, waiting for the 1 year, lost opportunity cost, and it's a bad outcome for everybody, right? I want to go back a couple, because there's a couple comments I want to mention. Physics still holds. So everyone has a touchpad on their PC, right? Everyone knows how, and everyone knows it's capacitive, right? How many people actually know how it works? Okay, one person, okay. Is that Greg? No.
Yeah.
Okay, it's because I told you. Okay. How it works is, you said the capacitance, right? Your finger's capacitance. It's really simple. Q equals CV. You're the C, and you measure the V. So Q is equal to IT. You just drive a current source for a certain amount of time, and you measure the V. Right? It's really simple. Right? And again, if you had thought about that, you would be a billionaire too, But isn't that amazing? It's just something simple. Q equals CV. That's all that is. Okay. When I talked about the divergence of E, the other day I was working about a month ago. You say, well, so what? Why did he bother using that? I was trying to come up with a coplanar microstrip, right? And you know what coplanar microstrip? Here's the ground, and here's the signal, and here's the ground, and then there's another signal here, right? So I was trying to figure out, okay, how big does the ground need to be given the signal, and here's the substrate, and I was like, I could look it up. I had to convince myself, and I remembered, the electric field lines always end and start at right angles on a conductor. That's always the case. So I can start drawing this, but I have to make sure. Okay, eventually I convinced myself that this 1.5 wide as this is the way to go. I didn't have to do any equations, but I just remember that divergence of E, which tells you this, that's why I applied it. Okay, and that's 33 years out of school. Okay, I just remember that. And before I go next slide, I'm gonna tell you the coolest invention I did. I gotta tell you this, because I was like, they'll get it. Okay, so back in the PC motherboard days, you plug stuff into a bus, and the bus operates at 8 megahertz. And everyone's trying to make graphics run faster. And the problem is the bus is standardized at 8 megahertz, but I knew this chip could operate faster. And in fact, I knew it could operate at 12 megahertz because I took a function generator and cranked it up. But the problem is the bus operates at 12. So I said, wow, so the bus is at 8. I know I can operate at 12. What can I do? So on the IBM PC, there's an address space, right? You start at 0, 0, 0, and then you go to FF, FF, address space, right, hex. And the graphics module I'm addressing is A0000 to B0000. And I said, okay. So basically, when I see the CPU addressing A0000, B0000, I'll just up the clock. And when it comes back down, I'll just move back to 8 megahertz. And I go, okay. sounds simple, and I forgot, how do you do that? Because I was asking them, can you dynamically, and they go, no. So I thought, oh, okay. And it took me a while, and I thought, here's what I'll do. You guys still do bubble diagrams? Maybe you don't, because I know our people, most people don't know what they are. 0, 0, 0, 1, 1, 0, right? 1, 0, 1. Okay, anyways. So what I did was I said, I'm going to divide by 3. I'm going to take 24 megahertz. I'm going to divide by 3, which gives me 8 megahertz. And when I see A0,000, B0,000, I do the address decode. I'm going to go here, and I get my divide by 2. So now I have a glitch-free clock. It's not 50% duty cycle, but the thing is, I either divide by 2, I divide by 3, and it's glitch-free because it's a state machine. And if I wanted it to be 50% duty cycle, I'll go 48 megahertz, right, divided by 4, divided by 6. Is that neat? It was brilliant because what happened was it maintained compatibility, all right, and anything on the bus, if it saw 12 megahertz, they didn't care because it wasn't addressed to it. The cycles were shorter, so it actually, it was turbocharging when it saw the address based on address decode, and when it went into another address, it just went back to standard cycle. I thought, wow, so that was a patent I thought was really, really neat when I came up across, because again, that's always, that's the new circuit that I wanted to invent, right, as a fresh engineer. Another thing I did that I didn't patent, and I should have patented, and I kind of regret it, but it's okay, it helps the world, was I was the person who decided to put clock synthesizers to generate the CPU frequency. At the time, you used to have a crystal or an oscillator, and you'd have to populate that in. So I was the person who said, let's use a PLL circuit, and you've got a VCO, right, that generates a certain frequency, right, and you divide by n over, and then you have a reference, and you divide that by m, and then you do m over n division, right, and basically, there's the error voltage, and you feed it back. Anyways, I was the guy who came up with that idea to use. So then now you just move a jumper to change clock frequencies. You don't have to change the crystal because you basically use a PLL, and you just choose different m over n divisors. So it's basically ref times m over n, and you choose your m over n ratios, and that generates the clock. And at the time, no one had done that. Everyone thought, just plug an oscillator in different frequencies, because at the time, Intel had, the CPU frequencies is a mad race, and they didn't know where they were, where the chips would yield at. This would allow them at manufacturing time just to move the jumper. So I was the guy who came up, but we didn't patent it. Okay. But at least I did it, and this is recorded, right, session, so it's history. And I got witnesses, and you guys can't leave. You're stuck here because it'd be rude to leave early, right? Okay. So some people told me they're parents of engineers, and again, I've managed hundreds of people, 100 people before, but it's always a guessing game between you and the manager. Okay, you always, I want more promotion, I want more. But you think about it, your manager is trying to get you the best, but I gave you a promotion. Well, yeah, but now I don't get the research stuff, or I don't get an award. Here's some ideas of what's important to you. Is money important to you? Title, level, time off, awards. When you talk to your manager and you want something at review time, tell them what's important to you. Because some people might say, money's not important. I want to work on more projects. I want to do some really cool projects. I want to work on a shipping product. I want something to work that's going to ship a lot. I want to go to conferences, right? Or, yeah, the title means a lot to me, right? There's different aspects of growth, whatever that means to you. And to you, it's different. Your manager's trying to guess what they think they're doing a good job for you, but it may not be, right? So let your manager know what's important to you, okay? And people say, well, how do I ask my manager for promotion? I always bring it up, and then they blow me off. This one, put it in the email in an agenda. Whatever you want to talk to your manager about, write it down, okay? Because then they know it's important enough that you emailed it to them, and that the topic's going to come up. They can't skirt it off and blow it off because you said it verbally and then they change the subject. It's there written down in email, and now they know it's important to you, and it's right there. And it's not like you're acting like a pushy person because you emailed it ahead of time. They're prepared. Okay. This is why I'm here. It's giving back, mentoring, help. As I said, 7 billion people in the world. As soon as you work, you're probably in the upper 10% of the world already. So we're all fortunate to be here. Even the fact that you're here is we're all fortunate, and I feel that way too. Think about others before you, your professors, your teachers, all the people who've done all the research, all the papers you read, all the articles you read. They've all given you this knowledge that you add to your toolbox, right? It's all stuck in your brain, and they gave for the goodness because they felt it was a good thing to do, right? So, funny thing at Intel, I was an engineer. I heard these two managers talking. One of them went to Notre Dame. He goes, "Yeah, I get that thing in the mail all the time. They keep asking for money," and I said, "I already paid my tuition. Get out of here. I already paid my dues." But remember, they chose you. Okay, Michigan chose you. Okay, they could have said, "No, we'll choose someone else." Yeah, yes, you paid your tuition, right? But remember, they chose you and the opportunities ahead. We're all fortunate. Remember, you're in the 10%. And so what I recommend is, and this was interesting, you can start with a small amount. When the time you feel maybe 3 to 5 years or whatever, you got student loans, but you feel like, okay, now I know I'm not going to be homeless and starving and stuff like that. I have the toolbox. I have confidence in myself, have some experience. I don't know, start with $1 a day or something, right? But just be consistent, because I remember, Judith, first time you met me, I said, "What are you seeing me for? I'm not this $10 million donor that I read in the magazine." But you said, "I'm consistent," right? You said, "You're consistent. That's the difference." And start with a small amount, maybe $1 a day. Like I said, when you're ready, just to let Michigan know you care, right? Yeah, you haven't, you're not a billionaire yet or 100 millionaire, but it doesn't matter. Just let them know that you remember being here, and that you care. It's just something you do every year, okay? And most importantly, when you do donate, because I know I get Rackham asks me, the UM asks me, I get phone call solicitation, direct your donation, okay? If you want to give to ECE, direct it to ECE. If there's a favorite professor you would like to support, direct it to the professor for the research, just to let them know. But if you don't direct it, what's going to happen is it goes to general university population. Yeah, it's goodness, it'll go somewhere. But again, if you feel like ECE really gave you something great, then direct it to ECE, start with a small amount when you're ready, and just be consistent just to say thank you, okay? So lastly, thank you for your time. I hope you got something out of this besides the cookie and the coffee. I think that was good. Hopefully you remember some stuff. You have a toolbox, and it's a Michigan toolbox with lots of knowledge. Like, remember me, divergency, solitons, and all that kind of stuff. That's in my toolbox. And do great things. You're, as engineers, right? Go change the world. You have the capability. You're in the major leagues now, okay? And remember who you got here, pass the knowledge forward, and you give back, give directed, okay? So, I figure you won't remember me because I'm an engineer, but maybe you'll remember that, some guy who worked on the Hololens Kinect gave some talk, and, hopefully something will resonate with you, and you'll take it back with you and do great things, change the world, because you have the toolbox, you have the knowledge, you're in the major leagues, you can do it, okay? And please do good things. Thank you. Thank you.
Wonderful. Questions?
Professor Wendell.
Just a comment. I'm so glad you gave this talk, because you mentioned electromagnetics, you talked about divergence of...
Oh, I thought you found out why you were born. or a third of a century.
So now I think our students understand why we ask them to take EECS 230, for example. 320, they learn about solid state and each the KT.
Oh, KT, there you go, yes.
How it all applies to things like Hololens and
Yeah.
Kinect and Xbox.
Yeah.
That's great. Thank you very much.
Thank you. Any other questions? Yes.
Just curious, so you're the fix-it guy, you're the one who commercializes, you're not the
Ideas guy.
famous scientist,
No.
the engineer who makes it happen. So
Correct.
what are you making in quantum computing?
Okay. Okay, this is recorded, so okay. No, it's okay. Yeah, firstly, this talk is my personal stuff, right? So I was very careful not to use Microsoft stuff, because otherwise they'd have to get pre-approved and all this kind of stuff. Okay, so in the quantum stuff, we talk about, I'm not the qubits, but I'm everything above the qubits. So it's how does the quantum computer eventually talk to the real world? Because we're going to put these in data centers. Okay, so you get the qubits, but what are you going to do with the qubits? They got to talk to some other processors and memory. So I'm on the systems group. I don't run it, but I'm an engineer on the systems group that is trying to solve above the qubits. Okay, how does it interface to the rest of the system? One thing I latched onto right away was, again, I told you at 4 Kelvin, it costs you every watt will cost you 200 watts of refrigerator power. So you can't just throw a bunch of stuff down at 4K. It's going to be a disaster because you're going to just blow out a bunch of heat. So the interconnect is a big issue. Okay, because if you use copper wires, copper is a great conductor of heat. Okay, and that copper will actually conduct heat from the room temperature down to the 4K domain, and you're going to pay a 201 penalty. So how do I transmit information from the rest of the world down to 4K domain? Well, maybe optical, but we found out that the photon efficiency is not 100%. Maybe it's high temp superconductors. Don't know. So I'm trying to find that out right now. What technique should we do? And that's where it comes in the quasi research stuff, right? That because usually product people are you all the manufacturing stuff. You're more of taking something that's existing or close to existing and productizing. Kinect was actually and Hololens are one of the further out where it was really pushing the envelope of productization. But this quantum stuff is like, well, this stuff doesn't even exist. We're going to have to invent something. So that's what, and I'm looking at different research stuff. That's why I talked about the resonant cavities. It sounded like great technology. I read this paper out of this lab, and then you talk to him and go, he's missing some techniques there. It's not going to scale. You can do one because you can tune the external laser, but it's not going to work in product. All right. So any other questions? Yes.
So you mentioned mentoring and giving back. How did you go about finding your mentors or the people who give you advice?
The mentor thing's hard. That's why my wife was actually the best one with me, because she knew me, and it's deep intimate. You'll talk to mentor, and usually that's tactical advice, like, oh, should I apply for this new job? What do you think? That kind of stuff. And I even went to career coaching, the career coaching and stuff. And she said, oh, what's your brand? And people would know your brand. It's like, it didn't work. So the mentoring thing is just like, did I do something stupid, right? That's really about it, right? Because I signed up for that, and then I was mentoring some people. But people, you kind of know what's right and wrong. You'll find your way along. But when you come to that point of what's better, then remember, why were you born? That's so important because everyone's different. And again, don't try to figure it out yourself, because you'll just fool yourself into saying, oh, I'm an engineer, right? It's not going to work. It's someone observing you from the distance. So the mentoring thing is useful, but I know Microsoft used to have a formal mentoring, then it dropped off, but occasionally you have a question, but someone's like, okay, should I apply for this job? How should I how should I approach this team? That kind of stuff for mentoring, but career mentoring, I haven't really found it useful. And so that was why that first slide of why you're born is so important. And it just clarified, because then I don't feel like, there's a lot of engineers that go, oh, I have to manage. They say, in order to grow, I have to manage. Well, you don't have to manage, but you feel like you have to manage because you feel that's the growth. But that's because you're measuring growth on a job grade or something like that, right? Versus me, I worked on these different products, right? And it's like, I can't be an expert on Xbox completely because I moved on to HoloLens, right? So by definition, I can't be the Xbox guy forever or Kinect guy forever, right? So, but that was a choice I made. Does that make sense? Okay, any other questions? No?
I'll ask the last question.
Oh.
Maybe. So you give some advice on 5+ years out, tips on how to face you in an interview. For our fresh graduates, what do they need to do to impress you? It's 2:30.
So, there's a lot of criticism when students come to campus. They go, they don't know the fundamentals. And I go, what do you mean? We interviewed some people and they didn't know Ohm's law. I go, get out of here, there's no way. It's like, really? And so there's project stuff that's important because people look at the project you did, but it will still ask you the fundamental, at least any group people I deal with, they'll always get to the fundamentals because they'll still ask you because they want to know, if you think about, okay, and when I've worked on the first HoloLens, that didn't exist, right? So by definition, no one had experience. So what they're trying to find out is who has fundamentals that could help us on this? HoloLens didn't exist, right? And so again, right, who has fundamentals that can help us pull through? Because it's not just picking components off the shelf and doing the integration exercise. And so they're looking for fundamentals like, well, an interview question I used to ask people And I don't ask this anymore, so I'll tell you what my interview question was. We're in the 1940s. And Khalil and I got this grant from some agency called NASA. And they say they're going to send people in space. And Khalil, the marketing guy, said, you know what, I'll do it. I know how to do this for a spacesuit. And he comes to me and he says, okay, Dawson, now we got to, how would you build the spacesuit? What are you going to do? Because by definition, there's no internet. Who are you going to go? What are you going to do? We got to do it because Khalil committed us. Okay, so what would my answer be? Well, we can spend hours and I can interview you guys, but so what I would say is, I'd go to, what do people use for fire suppression? What do deep sea divers do? I'd go to universities and find out what materials exist, right? You build upon the prior knowledge, right? Right, and then I'd say, we'd send some stuff up in space and, measure the vacuum. That's the kind of thing. Well, fundamentally, how would you attack the problem? Now, of course, I should back up. Number one is, what's the specification? Okay, that's always the trick. If you don't ask for specifications, forget it. Okay, because you can't hack things, right? Number one, what are the specs? And if they don't have specs, let's go find the specs. Let's go send some things up in space, some weather balloons, and find out what the environments are, and so on and so on. But you're building upon knowledge from other people, right? You can't just get a spacesuit out of nowhere unless you know some aliens, right? And they just give it to you, right? So otherwise, you're going to have to build upon deep sea divers, hot environments, people work in iron mills and all this kind of stuff, right? Casting and then pressure stuff and radiation and so on. Are you gonna, go to those guys at Lawrence Livermore work on nuclear stuff? What's radiation tolerant? So you're always building upon prior knowledge, right? Which is why, again, yeah, you paid your tuition, but you didn't pay the tuition for Aristotle or Einstein. You didn't pay tuition for him, right? Yet you're using the knowledge from all these people, right? Right, and hopefully you got something out of me, but I don't expect anything from you. I just want you to pass the knowledge through, as hopefully before 33 years, you'll pass knowledge too that you learn along the way to other people. Because, Wendy and I really believe in students because, I remember, she homeschooled the kids because, the most important job in the world is raising children, right? And, you're students and, you're going to do great stuff in the future. It's most important that you guys get great education, you have right values, and you do the great things in the world. And that's partly why I'm glad I got the opportunity to talk to you here. And I'm glad they brought cookies and coffee to get you guys enticed to come here. Otherwise, I might not be able to tell you all this, okay?
Let's thank
Thank you.